Well, hey there, it's your old pal, Mr. Cook. We've got through the first four. Let's do 5 and 6. So here we go. Ready? Five. Let's see. What method am I going to use here? Well, first off, if you have linear equations, right? Like you do your little substitution or your elimination, and I'm going to tell you something. If you switch over to nonlinear equations, uh, you're still going to use the exact same thing, substitution or elimination at this level until we get some better stuff, maybe. So let's see what we would do. Like if I saw that second equation, I'd say, hey, that's a prime candidate for substitution because I can get that y value all by itself pretty easily. Yeah, let's do that. So I'd add the x over and I'd get y is equal to a positive x minus 3. Okay, and now that I've solved for y, it's the same y as this equation. So I'm going to take the other equation that I haven't touched yet, and I'm going to replace that y value, any y value that I see in there, with x minus 3. So that's what I'm going to do. So let's see, y becomes x minus 3 equals x squared plus 3. Then let's see, what would I do? This is a quadratic because of that x squared. So I'd probably move all this stuff over to the other side. So I'd turn that into 0 basically. So I'd have x squared plus 3. And then I'd subtract away x on both sides. And I'd add 3 on both sides. So let's make this look a little bit nicer. Let's see, 3 plus 3, that's 6. And then let me rewrite that, negative x and then a plus 6. There we go. All right, so are there any numbers that multiply together to be 6, add together to be negative 1? If you said negative 3 and positive 2, you're wrong, right? Because negative 3 times positive 2 is like a negative 6. So like if that was a minus 6, that'd be really nice, but it's not. So we're not going to be able to factor this thing. So instead, let's use a quadratic formula. Let's see if we can get some solutions this way. So x equals negative b, so negative of negative 1 plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c all over 2a, so 2 times 1. And that's not really going to matter much because watch what happens. So the negative of a negative is a positive, so 1 plus or minus, 2 is in the denominator. Oh boy, look at that discriminant. We get negative 1 squared, 1, minus 4 times 1 times 6, which is 24. So we get a negative 23. See, here's the deal. When we're trying to get solutions for systems of equations, we want real solutions, but this is only going to lead to imaginary values. Okay, so there's no real solutions to this one. So we write no real solutions for this. However, if the question was prompted and we needed to find like complex solutions, we could do that. All we'd have to do is then just say that we take the negative out of there. So we'd have 1 plus or minus pi times the square root of 23. You guys remember this stuff? Over 2. And I mean, technically, theoretically, you should be able to solve for the corresponding y values the exact same way. They'd just be, complex as well. So like if you had y minus x equals negative 3, you could plug in your x values and all that stuff. But, I'm pretty sure you don't have to do that for this unit. So, just let's leave it at no real solutions, okay? And do you want to know why it's no real solutions? If you got out your graphing calculator, here's what you would see. So if we graphed out these two equations, let's move the x over there so my linear equation is a little bit easier to graph. There we go. So I'd go down 3, and then my slope would be up 1 over 1. So I guess I'd be able to get through the x-axis at 3, 0. Okay, so it looks something like that. And then my parabola starts like going up 3, 1, 2, 3, and then a parabola takes over. So here's what ends up happening, right? The parabola and the line never meet up. So there's no solutions where these two lines intersect. There's no intersection point. So that's why that ends up happening. Okay, for the next one, it looks like we've got a circle and then also a linear equation. So let's use the exact same stuff to solve this out. Okay, I'm gonna probably use substitution here again. Let me take that x and get it in terms of y. So x equals y plus 3. And then I'm going to go ahead and plug it on in there to that equation. So let's see, we've got y plus 3 quantity squared plus y squared equals 29. And then, we distribute this or FOIL it, whatever you want to call it. It's y plus 3 times y plus 3, and then plus y squared equals 29. Distributing, we get y squared plus 6y's. We get 6y's in total, and then plus 9, and then y squared. So let's add those y squares together. Now we got 2 of them. Okay, now let's see. What else can we do? Well, it's a quadratic again, so I want to get this side to be 0, so I'm going to subtract 29 from both sides. So I'd get 2y squared plus 6y, and then 9 minus 29 is negative 20. And then I see that I've got a bunch of like even numbers here, a 2, a 6, and a 20. I'm going to divide both sides by 2. Okay, so divide all that by 2, even the 0. And here's how I reduce it a little bit further. Y squared plus 3y, and then 20 divided by 2 is 10, so minus 10 equals 0. Oh boy, I like that because that quadratic I can probably factor. Let's see, I need to find numbers that multiply together to be negative 10 and add together to be the middle term 3. So that'd be a positive 5 and a negative 2. That does work out. So let's write it up in factored form. That'd be y plus 5. And then y minus 2 equals 0. So I'm going to claim that y can be equal to either 2 or negative 5, one of those. All right. So now let's check to see where these points, where these y values potentially could go. So 2 and negative 5 are the y values on my little ordered pair. 2 there, negative 5 there. Let's see what the corresponding x values would be. So I'm just going to use my linear equation. That's like the easiest one to use, right? And remember, the ordered pairs have to pass through both equations. So let's, just use the easy one, the linear equation. So x minus one of my y values, let's pick 2. Okay, let's go 2 first. Y minus 2 equals 3. So that means that x has to be equal to a positive 5. So 5, 2 is one of the ordered pairs. And then the other one, let's use the other y value, negative 5. So y minus negative 5 equals 3. So that means that x plus 5 equals 3. And that means that x must be equal to negative 2. So negative 2, negative 5. Those are the ones that work for the linear equation. And I bet you anything that if you took those same exact ordered pairs and you plugged them into the circle, they'd work for that thing too. Bet you anything. Okay, so there's the work for that. Maybe we'll do like 1 or 2 of these word problems. I don't know. Let's do number 7. Let's see how much time it takes. So number 7, the perimeter of a rectangle. Well, geez, perimeter of a rectangle. That's like, okay, so I don't have any diagrams. Here's like my big advice for word problems. Draw a diagram, okay? If it references a shape, a triangle, a rectangle, a circle, whatever, draw it out, okay? Or draw a diagram. Like number 8's probably really nice for a diagram. Let's see how that looks. Okay, so perimeter of a rectangle. So let's draw the rectangle. The perimeter, it adds up all the sides. I don't know anything about the sides, but on a rectangle, I know that like the sides across from each other are the same. So I'll just call one side x, then the side across from it's going to be congruent. And then one of the sides y, and the side across from that's going to be congruent as well. So let's see here. The perimeter of the rectangle is equal to 44 inches. So P equals 44 inches. And sometimes when you guys do like word problems, your teachers ask you to label stuff. So I'd say that like, X, well, let's hold off. Let's hold off on labeling your variables. This is what happens with your rectangle. Let's read the rest of the information. Perimeter equals 44. If the length is increased by twice the width, the result is 31 inches. Oh, okay, wait. So I guess it probably is a good idea. Let's call X the width of the triangle. And then Y we'll call the length. Oops, darn it. So if the length is increased by twice the width, so we draw another rectangle. And, let's see, the length is increased. So the length is Y. If Y is increased, in other words, added on, by twice the width, so 2 times the width, which is x, then the result is 31 inches for the perimeter. Find the length and width of the rectangle. I've got to read that more closely because I think that if it says 44 inches and then 31 inches, if the length is increased by twice the width, I would have thought that the perimeter would have to be like larger than that. Find the length and the width of the rectangle. I think that they haven't changed the width, so let's keep the width. If the length is increased, so adding, by twice the width, the result is 31 inches. Maybe it's 31 inches more. I don't know. Find the length and the width of the rectangle. Well, I'm actually a little bit stumped because I would assume that it's going to be more than the perimeter. You know what? I'm just going to go through the problem and see what happens. So, all right, if the perimeter on this one is 44 inches, let's write it up the way that it's intended. So the result is 31 inches. Oh, I'm an idiot. Okay, I understand what they're saying. The length, not the perimeter. The length is just 31 inches. I thought that implied like the perimeter for some reason. I totally misread it. Well, hey, that's probably a lesson. Make sure you read it carefully, because that took me back, but it sidelined me for a couple of seconds. So it just says that if the length is increased, so if y is increased by 2 times the width, so 2 times x, then the result is 31 inches. It's just setting up one equation for that. And then the other equation we get is from the perimeter. So the perimeter is all the sides added up. So over here, right, like if we use 44 inches for all of the sides added up, we have 2 x's and 2 y's. And if we add them together, that gives us 44. And this is our system of equations that we can work with. Y plus 2x equals 31. Maybe I'd like rearrange these to 2x plus y equals 31. This is probably a prime candidate for elimination. So I'd probably like subtract the bottom equation from the top equation. And here's what I get. Let's distribute the negatives in there. So a negative 2x, a negative y, and a negative 31. Add them up and we get 0x and 1y. And 44 minus 31 gives me 13. So 0y goes away. So, oh, great. Y, the length is 13. Oops, why did I erase the word length? Equals 13. There we go. And then I can go right back over to this equation probably and solve for x. So I'd have 13 plus 2x is equal to 31. If I subtract 13 from both sides, 2x would be equal to 18. And that means that x has to be equal to 9. So it's like 9. Okay, and then let's see, I guess the units in this case are inches. So I put inches on there, and that would give me like full credit. So the width is 9, the length is 13. And you can double check it, right? Like make sure that the perimeter is 44. So if I, change these back into those numbers, x is 9, y is 13. I bet you anything that they'll add up to that 44 that we're hoping for. Okay, so there you go. There's number 7. A little bit of a hiccup there because I just had a brain fart. Couldn't really picture what the question was asking, but that's on me. It's actually like pretty well written. It says the length, so whatever. An airplane flies 500 kilometers against the wind in 2 hours. Oh, I like these problems. It flies the same distance with the wind in 1 hour. So like if you've got an airplane, right? So here's my little airplane. And if it's flying like into the wind, right? That means that the wind's going against it. It's going to slow it down. You probably have some reference in your mind to this, right? Like, have you ever been riding your bicycle or riding a skateboard in the wind? It's like pushing against you. It slows you down. Like you have to paddle harder to get farther away. It's because the velocity of the plane and the velocity of the wind are going against each other. They're like subtracting each other. Now, if you're going with the wind instead of against it, then the wind's like pushing at your back. and you feel like you're going a lot faster. So that's like adding, okay? So that's like the first idea. If you're going against the wind, right, you're subtracting the two values. If you're going with the wind, you're adding them. So that's like the first thing. Let's see what else it asks us. It says an airplane flies 500 kilometers against the wind in 2 hours. It flies the same distance with the wind in 1 hour. What is the plane's speed in still air, i.e., in no wind? So this is what we're trying to solve: the velocity of the plane without any wind. So VP, that's what we're going to try and look for. Um, the other thing that you need to have memorized for this is this relationship. Okay, I'm going to give you a very basic, not 100% accurate, but basic representation of what speed is. Okay, it's like the total distance traveled, okay, divided by the time that it took to travel that distance. Okay, and as a result, we can also solve for the distance traveled. So if I multiply both sides by t, I get the distance traveled is equal to the speed that it's traveling times the amount of time that it took. So that's how I'm going to end up solving for this. Like each of these like speeds or velocities that I have here, I'm going to replace them with the distance that they're going to travel with it. Okay, so here's how it's going to go. Are you ready? The total distance traveled is 500 kilometers either way. And that 500 is, from this formula right over here, where like it's the net speed. So either adding or subtracting times the net amount of time. So the total amount of time that the plane's in the air. So that 500 for the distance is going to be equal to the speed of the plane. So we'll call it SP. I said V because I'm used to writing velocity, but it's the speed of the plane and the speed of the wind. So the speed of the plane times the amount of time that it took to fly against the wind. Okay, so that's 2 hours. So times 2. And then plus the speed of the wind times that same amount of time, 2. Okay. And then we're going to do the same thing with flying with the wind. So with the wind means that oops, and I should have subtracted. My bad. I'm sorry. I made a little mistake. Since it says that it's against the wind, these should be subtracting each other. The other equation, since it's going to be with the wind, they need to be adding together. So it's going to be the speed times the time plus the speed of the wind times the total time. And that's going to be the same distance, 500, because it goes the same distance there and the same distance back. And the amount of time that it took to travel that distance with the wind was 1 hour. Okay. So what we're going to do now is write this up as a system of equations and then solve. Okay. So I'm going to make these variables a little bit easier to manage. Okay. The speed of the plane, I'm just going to call that x. So let's call it x. X is the speed of the plane. And then we'll call that y. Y is the speed of the wind. And let's, replace these variables in there. So those are x's there. And those are y's right over there. And let's put the coefficients out front as well. So I've got 1x and 1y. And then 2 y's and 2 x's. Well, geez, this is like way easier than I could have imagined. Look at how easy that system of equations is. It's like way easier. So I guess the hard part is the setup for this, right? After that, it's just keep going with what you got. So let's solve this up. What I would do is I'd probably multiply. Let's see. Yeah, I'd probably. We haven't done it in a while. Let's do elimination. So I'm going to multiply this bottom equation by. Let's cancel out the y value. So I'm going to multiply the whole thing by 2. So here's what I end up with. Ready? The top equation stays the same. 500 equals 2x minus 2y. And if I multiply the whole bottom equation by 2, I distribute everything in. 2 times 500 is 1,000. 2 times x, that's 2x. And then 2 times y, that's 2y, positive 2y. And if I add these two equations together, here's what I end up with. I get 1,500 is equal to, and then 2x and 2x makes 4x. Negative 2y and 2y gives me 0y, so that's gone. And I get this really easy equation. 1,500 equals 4x. So if I divide both sides by 4, oh gosh, I think that's 375, I believe. If I divide by 4, I think that's right. Oh, let me get my calculator. Hold on. I never trust myself. 1,500 over 4. Yeah, 375. I should have believed in myself. Okay, so 375, that's equal to the x value, not y. Gosh, I'm making all sorts of little mistakes right now. Okay, so x is the speed of the plane, and that's like exactly what we wanted. So we just solved the question. X is equal to 375, and then let's see, it's kilometers per hour. That's going to be the speed, okay? Because it's always the distance over the time. So kilometers per hour. All right, I think I've been babbling on a little bit too long for this video, so we'll call that one the end of this one, and then we'll do number 9, number 10, number 11, and number 12 in the next one. Okay, I'll see you then. Bye-bye.